Well, hello guys. Today we are going to study a little bit more about this Desmos app that I've been telling you about. So let us get started with something simpler. Like, for example, how do you draw simple polynomial functions and how do you restrict their field, their domain? First of all, we can start with a simple function like y equals 10 minus, sorry, 10 minus 2x. Now the usual variables that you're going to work with are x for the independent variable, y for anything else, or even some function like f of x, g of x, etc. So you see that what we got here, let's start with the projector mode. This over here is the projector mode. You can turn it on or off. It's on the little wrench over there, and it shows you thicker lines so that it's more understandable. Now, this is of course a simple linear graph, but we can actually do something with it because sometimes we're not interested in the whole graph. Sometimes you want only a little part. For example, imagine that you only wanted values for x that are greater than 0. Then you can actually tell this app to only draw this part of the graph. See? As I told you before, you can pinch this to make it look flatter. Also, if you want to go a little deeper into this, if it's 10 minus 2x, you know that it's going to cut over there at 5. So you can actually go to your restriction and also tell you that x has to be less than 5. And so that way you have restricted the function. Notice that if you tap on the function, there are a few points of interest that it's going to show you. In this case, one of them is the y-intersection of the graph. The other one is the x-intersection of the graph. They disappear when you tap anywhere else. So that's a linear function for you. Also, let's make this go away. You can graph functions by using this notation, f of x equals something. Let's say that you're going to work with a parabola, a quadratic function. So that's your parabola over there. Let's look at it a little bit bigger. Now, you can see right away that you can also restrict this one. For example, let's restrict this parabola between -1 and 4. And if you do that, see what you get? It's just a little bit of the parabola. Now, if you tap on the graph, there is only one little bit of one point of interest here, which is this one. That's because the intersection of the function is the same as the lowest point on the function, but you don't have to do it that way. Let's make this one go away and let's draw now. We have to use another letter. G of x equals 4 minus x squared. And this is what you get. Now, how many points of interest are we gonna get here? Yes, you guessed right. You have 3. One of them is the intersection with the x-axis, another one is another intersection with the x-axis, and another one is the intersection with the y-axis. Now this intersection with the y-axis, sorry, also happens to be the highest point in the graph. But sometimes that's not so. Say for example that you have this following one. We're gonna call it h of x equals negative x squared plus 2x. And you can see right away that one point is 0, 0, another is 2, 0, but the third one is 1, 1. And the reason that you have this point is because that's the highest point in the graph. If then you restrict this between 0 and 2, because that's where the, sorry, and 1, because that's where the highest point occurs, then you get exactly half of this part of the parabola. Now, you can also slide your finger like that, and that's gonna give you several different points all along the graph. It's sort of like a bead that you can slide forward and backwards, okay? Finally, you can also draw. Let's use now a number like this. You can use f1 of x, and you can draw functions that are a little more complicated. Like for example, you can draw a function that like x to the third power minus x squared, and you get something weird like this. Look at the shape of that thing. Looks like a little snake. That's your function. And that's how you usually work with any type of function. So, what have we learned? We learned that you can restrict the function, and we learned that you can find points on the function. See, for example, here. And you learned that there are more complicated functions that we have studied. So, you better shape up, guys. See ya.